Question number 5. So I have these two curves. Find the coordinates of the point of intersection labelling A and B in the diagram above. So no decimal places, so I've got to get the exact, so I'm going to enter them into the calculator. Here they are. If I bring up my graphing window, edit, you're all okay. Take that one, take that one, and I'm only doing R plus, so I'm only looking at the area down here. Beautiful. And I'm looking for the intersection point, so I'm going to make that equal this. And I'm going to go interactive advanced, solve for x, okay, make sure I'm in standard. So I'm looking at a half. So that's going to be, A is going to be a half, and then I can find out the y value. And I'm going to have this one here, which will be the plus. So I'm going to have b is √3 plus 1 on 2. And then if I take this and keyboard math 3 given x equals a half, I get negative 2/5. And if I take this answer and execute, I get that, and I simplify that answer, end up with -2 square root of, √3 plus 1 all on 5 as being the two x-intercepts. I could do -2 √3 -2 all on 5 as being the y coordinate as well, just as easily. Okay, determine the area bounded by the graphs given in A and B, given the form of that. Okay, so it's the area of, so it's 2 marks, so I need to write definite integral. It's going to go from 1/2 to √3 plus 1 on 2 of top curve is g of x minus f of x dx. So there's my one method mark. Now my calculator, I will do that. So I've got 1 divided by 2, and I've got this one here, so copy, paste. Try and get into the habit of doing exactly what they've got here, and don't try and retype them. Paste. Minus, and I'm going to go math 1, open up a bracket. So when I get this expression up here, which has positives and negatives in it, I'm just going to put it into the bracket so that my signs end up correct. And that's dx. And that gives me an answer. And if I press simplify, it gets it in the form that I want. So I'm now going to go answer and go combine, interactive transform combine. And it's exactly the way I want it. I've got -9 plus 6 √3 on 10. And double check that, is that a positive answer? It is a positive answer. And if I come to here and I do analysis, G solve, integral, intersection, I'll accept the first one, yes. Come across to the second one, yes. And I'm looking for 0.13927, and that's exactly what I got up here. So I know that that answer is correct. Beautiful. So that's part B. Part C, we now move into A territory. And I've got to find the value of A for which this equals this, and given A is times mb(x squared), I believe that A equals 5. So I could say copy, paste, that equals this, which is bracket 1 minus variables A close bracket x divided by a, and I want to solve it for a. And a equals 5. Beautiful. Find the positive x-intercept of P in terms of A. So the positive x-intercept of P in terms of A. So I want to make P of x equal to 0. So I'm going to have, so I've typed it, I'm going to make it equal 0 and go solve for x, interactive advance, solve for x. That gives me these two. I want the positive, so it's going to be x equals 1 on the square root of a plus 1. M lies on the graph of P of x. The tangent to P of M is parallel to Q. Well, the gradient of Q is going to be 1 minus A on A. So I want the tangent at P. So I want the derivative of x to equal 1 minus A on A and solve for A to find out the coordinates of M, or solve for x. Okay, so the derivative of this, so if I take this is my curve. I wish to take the derivative of that. I want to make it equal to what is it? 1 minus A. Solve for x. So I'm going to get A equaling. So this is where the tangent's going to touch the curve at x equals 2 to the 1/3 over A minus 1 to the 1/3, or 2 on A minus 1 cubic root. So that's part E done. So F, find the y-intercept of the tangent to M at M. Okay, so I want to copy that. I'm going to take my curve. This is my curve. Take that down on your line. I'd like to find the tangent. So calculation line, tan line, and I copied that value of M, and I'm going to paste it there and go OK, and then go simplify the answer. So these are the terms that have x. So these are the terms that are the y-intercept. And I'm just going to write it out. It's worth 1 mark. So the y-intercept is 0 and 3 times 2 to the 1/3 times A minus 1 to the 2/3 over 2A minus 1 on A minus 1. So that's going to be the y-intercept. Given that this show that is parallel, show that the y-intercept is negative. Okay, so this is my y-intercept. 3 times 2 to the 1/3, A minus 1 to the 2/3. Minus 1 on A minus 1 is the y. So I want to show that that is less than 0. That's what my proof is. So if I've got this here, then this is this, but in terms of x. But I need a 3. So if I move this 3 over, so I've got, if I could make x equal to A, then I know that 2A is bigger than or equal to 3 times 2 to the 1/3 times A minus 1 to the 2/3. So I can replace this with 2A minus 1 on A minus 1. But remember, I have a divide by 2A, I missed, so divided by 2A. They cancel, and 1 minus 1, I get negative 1 on A is less than 0, and A is bigger than 1, therefore -1 on A is less than 0. Therefore, that's true. Okay, the tangent to P is parallel to Q, has a negative y-intercept. So I know that Q goes through the origin, and if P is parallel, then we're going to have an intersection point, because so we know that there'll be an x-intercept or an x-intersection because A is bigger than 1, and that's going to be positive. So we know that that will happen, and we know that the tangent that you're attaching to this curve is going to be less than 0 because it's negative. Therefore, there's going to be 2 intersection points, and it's going to be a region which will be enclosed. And lastly, I know that that's going to be a point that is going to be linked when A goes to 100. This is my trapped area. As A gets bigger and bigger and bigger, this is going to approach a rectangle of area 1/2. Therefore, the maximum value of B being the shaded area, so B has to be less than 1/2, so B equals 1/2.